let's do an integral using a method. I'm going to call this the first substitution problem. And I'm going to make it be an integral we could do without a substitution so that we can check the answer in another way. And here's the integral. Integrate, indefinite integral, 2x times x squared plus 1 quantity squared. What is the substitution method? It's a way of simplifying the integral in a way that makes it easier to guess the answer. And it's not always clear what substitution you should do. But I did make this one fairly easy. You want to let a new variable be something in this function whose derivative is also in this function somewhere. Hey, I can see the derivative of x squared is 2x. The derivative of that is there. It's going to be better to let my new variable be x squared plus 1, whose derivative is also 2x right there. In most calculus books, substitution is called U substitution. In our calculus book, they try to buck tradition and they use a different letter. They use W. There's a good reason for that. It's because they don't want you to get mixed up with the next method, which is called integration by parts, which uses the letter U. So conceptually, they're trying to avoid confusion of the methods. There's another benefit of using W, in that when you take its derivative, you get to say dW. Hey, Arthur. My kids are in my 20s. My kids are in their 20s. Yeah, they watched a lot of Arthur growing up. That's the only time I'll say that. But you can say it in your mind. Just don't say it out loud during the exam. dW equals 2x dx. What did I do there? I differentiated this with respect to x. Why did I not write dW dx equals 2x? Well, I could have. But then I could get from here to here by quote unquote multiplying both sides by dx. But wait a minute, is dx really a number? Here's a dirty little secret. No, it's not. So how can you multiply both sides by dx? Here's another dirty little secret. It doesn't hurt to pretend it's a number. Huh? Yeah. And this happens a lot in calculus, especially calculus 2, is to pretend these things are numbers and to pretend this is a fraction and pretend I can cross multiply by dx. The best justification at the moment for why this is okay is it gets you the right answer. Why are we okay with just a hand-wavy justification? Because a full justification is really, really hard. There's two ways you can justify it. One is using something called infinitesimals, and another is using something called differential geometry. And those are both graduate school level topics. But for us, we're happy it gets us the right answer, because now we replace x squared plus 1 with w, and we replace the 2x dx with dw. And the integral becomes the integral of w squared dw. Don't forget the square. A much simpler integral. I can do it really quick. 1/3 w cubed plus c. Don't forget the c, because this is an indefinite integral. But you should not stop there. You've got to go back to x at the end to get 1/3, replace w with x squared plus 1. And there's your final answer. Don't forget the plus c. And you can check this, differentiate it. We should get that. Differentiate the c, you get 0. C doesn't matter. Differentiate this, I need the chain rule. Think it with me in your mind. Bring down the 3. 3 times 1/3 is 1. 1 times x squared plus 1 squared, I subtract 1. Then with the chain rule, multiply times the derivative of x squared plus 1, which is 2x. exactly this function right there. It works. Here's another way to check it. Let's do this integral another way. Let's expand it. FOIL x squared plus 1, multiply it times itself. If you do so, you'll get x to the fourth plus 2x squared plus 1. Then multiply the 2x through the parentheses to get 2x to the fifth plus 4x cubed plus 2x. And then do that integral, you'll get 1/3 x to the sixth plus x to the fourth plus x squared plus c. That's also a correct answer. Are these the same answers? Well, let's try expanding that out and see if they are. It's a cube, a binomial cubed. I can't FOIL. I can use something called the binomial theorem, which comes from Pascal's triangle. I'm not going to explain it, but here's the answer that you will get if you do it. Now multiply the 1 through the third through the parentheses. Simplify. Uh-oh, wait a minute. There's a 1/3 there, but there's no 1/3 there. What's wrong? Different c's, yeah. The 1/3 is a constant. It could kind of get absorbed into that c. Or maybe you prefer calling this C1 and this C2. You don't have to do it that way, but could. It is effectively the same answer. It is the same family of functions that all differ by a constant. Graphically, if you graph these, they're all vertical translations of each other. And they have the same derivative, same slopes everywhere. Okay, so we didn't have time for a participation thing today, but I am aiming to do one for Friday. But that's it for today. Have a good day.